Good morning, everyone. In previous class, we discussed about introductory class of sequential circuits. In that class, we discussed about the combinational circuit and sequential circuits, and some of the examples we have seen off adder and counter we have seen. Coming to the applications of sequential circuits, those are flip-flops, counters and registers. In that, three basic elements that are present in sequential circuit is, first one is a memory block. A memory block which is more important in sequential circuit because the past history of output we have to store in that memory block. The two memory blocks we are used in sequential circuits, one is flip flop and second one is latch. What is flip flop and what is latch and what are the different types of flip flops, we will see one by one. In this class I would like to explain SR latch functionality and how it store a single bit binary number 0 or 1. If I know how to store a single bit binary number, I can able to store a multi-bit binary number also. As you are in a digital world, you need to store a big data. If you want to store a big data, first you need to know about a small data has to store, that is a single bit binary number. Let us see how it works, this SR latch, how it works in SR latch. The internal circuit of SR latch is two types of circuits are there, using NOR gates and using NAND gates. First we would like to explain NOR SR latch. In coming slides I would like to explain NAND SR latch. In NOR SR latch I am using two NOR gates, two cross coupled NOR gates, and inputs are S and R, outputs are Q and Q bar. Inputs are S and R means S means set, R means reset, Q means normal output, Q bar is complementary part of normal output. If I know normal output, the complementary part can be easily obtained because it is complement of normal output. In digital systems, set means the output function is going to be high, and if we want to make the circuit should be in reset, reset means the output should be 0, that means low. In the coming slide, and before going to coming slide, what is the use of clock signal? The basic difference between flip flop and latch is, flip flop is a memory block which can store a single bit binary number, but we have a control over the input combination. It cannot change instantaneously or accidentally. With the help of this clock signal we can able to control the input signal. That is the major important point you have to know. And in latch it is a non-clocked flip-flop. Latch is nothing but it is a non-clocked flip-flop. It cannot be controlled. We cannot have a control over the input combinations, whether it is 0 0 or 0 1 or 1 0 or 1 1. If we have two inputs, we have a four combinations. We have to check for four combinations in this SR latch, how it will be stored. In the next slide I like to explain about this truth table of NOR gate. If I know this truth table of NOR gate, I can able to complete all this explanation easily, because you see that if I have two inputs, A and B are two inputs, Y as output. If you see we have a four combination. If I have two inputs, we have four combinations. Those are 0 0 0 1 1 0 1 1. For 0 0 only we are getting the output is high, remaining three combinations the output is low. From this I can able to make a one statement, that is if any one of the input of the NOR gate is 1 or high, the output is low or 0. By using this statement, I can fill all these output values easily. I have to check this NOR SR latch with these three cases, and every case I have to check with S is equal to 0 and R is equal to 0. Whether that previous output is same or not, we have to check it, because our ultimate aim is to store a single bit binary number, whether it is 0 or 1. Coming to this first case, if I give S is equal to 0 and R is equal to 1, if S is equal to 0 and R is equal to 1, on right hand of the slide the first picture or first circuit will show when S is equal to 0 and R is equal to 1. That means, you see, if any one of the input of the first NOR gate is 1, that means the output is going to be low. It is observed from the truth table of NOR gate. Did you observe or not? You see, once again I am explaining. If any one of the input of the NOR gate is high, the output is going to be low, and this Q is given to this second NOR gate. That means 0 0. If I give 0 0, the output is 1. This is satisfied or not? It is satisfied. That means there is no problem for the output combination. That is, Q is 0 means always the Q bar is 1, because it is complementary part of normal output. Next, we have to check for the second combination, that is S is equal to 0 and R is equal to 0. If S is equal to 0 and R is equal to 0, you see, these are the previous outputs. Q is equal to 0 and Q bar is equal to 1. You have to take this previous output as present input. That means, let us take Q is equal to 0 to second NOR gate. What happens when we give 0 0 to NOR gate? We are getting Q bar is 1. If you consider this Q bar is equal to 1 to this first input of the NOR gate, first gate of this NOR gate, 0 1. 0 1 means, from the truth table I can observe Q is equal to 0. You can observe here, for S is equal to 0, R is equal to 0, we got the same values as previous outputs. That means this state is called it as memory state. When S is equal to 0, R is equal to 0, we got Q is equal to 0 and Q bar is equal to 1. The same values are repeated. That means this state is called memory state or no change state. In coming slide, we are going to see the second case number 2. That is, when S is equal to 1, R is equal to 1. In every slide, I am going to give two internal circuits. Those are, for first case is S is equal to 1, R is equal to 0, and second circuit is S is equal to 0 and R is equal to 0, with the help of previous states. Whether these values are changed or not, you have to check it. If it is not changed, that means it is called memory state. If it is changed, means it is, whether it is not used case, or it can be called it as no change or memory state. You can see the case number 2. S is equal to 1, R is equal to 1. From the second NOR gate, you can observe, if any one of the input of this NOR gate is 1, the output is going to be 0. That means Q bar is equal to 0. This Q bar is given to this first one of the input of this first NOR gate. That means 0 0. For 0 0, from the truth table of 2 input NOR gate, for 0 0, the output is going to be high, that is 1. Is it satisfied or not? You can check. If Q bar is 0, we got Q is 1. It is satisfied. It is true statement. Next, with the help of this combination I can check whether it is changed or not. You can observe here I am changing with the values 0 0 from 0 1. You can observe s is equal to 0 I changed and r is equal to 0 I changed in this case too. And I can observe from the previous state values I am written here whether these values are changed or not. You can check. You see this q is equal to 1 is taken here. That means the second input of this NOR gate is 0 1. If 0 1 is given to this second input second gate, what happens? If any input of this NOR gate is 1, the output is going to be high. I already made a one statement from the truth table of NOR gate, that is if any one of the input of this NOR gate is 1, the output is going to be low. If q bar is 0, this q is always 1. Whether it is getting or not, you can check from this circuit. Q bar is 0 is came to here. That means when first input of this NOR gate is 0 and the second input of this NOR gate is 0. For 0 0 from the truth table I can write q is equal to 1. The output is going to be 1. This is also satisfied. You see, when s is equal to 0, r is equal to 0, for this case also the same values are repeated. That is q is equal to 1, q bar is equal to 0. Okay. Next, last case is 3. This case is very much important and it is somewhat confusing also. You have to see clearly without making any problem. You can understand easily. When s is equal to 1, r is equal to 1, we have to check whether these values are satisfied or not. The normal output and complement output are uh, satisfied or not. You can check. When s is equal to 1, r is equal to 1, what happens? If any one of the input of this NOR gate is 1, the output is 0. Okay. And this also, when s is equal to 1, any one of the input of this NOR gate is 1, the output is 0. That means q is equal to 0, q bar is also 0. Is it true statement? No, it is not a true statement because it always complementary each other, complement to each other. Q and q bar should be complement to each other. Because of that reason, it is a not used case. It is a not used case. And next one, you can observe the every case you should study with s is equal to 0 and r is equal to 0. Whether these values are changed or not, you have to check. You can observe I am changing with the values s is equal to 0 and r is equal to 0. And let us consider q is q as first and next q bar is second. Okay. When q is taken as 0, that means 0 0, we got 1. And next one is when q bar is taken as when q bar is taken as 1, that 1 is getting here. For r is equal to 0 and second input of this first NOR gate is 1. For 0 1 we are getting 0. That means q is 0, q bar is 1. It is same. But if we consider q bar is 0, if we consider q bar is 0, if we consider q bar is 0 means q bar 0 is getting here. For 0 0 we are getting 1. That means q is 1, q bar is 0. For the same combination we are getting two types of output combinations. For s is equal to 0, r is equal to 0, for by considering q we are getting one value and after that we are changing that values. It is not at all suitable. For that reason, this case 3 is indeterminate state or it is a not used case. It will be not used by the combination. Because of this reason, it is not used case. Next, From this I am making one table, that is truth table of this SR latch, that is S and R are inputs, Q and Q bar are outputs. By from these three cases I can observe for 0 0 it is a memory state. For 0 1 Q is 0, Q bar is 1, that means it is reset state, because Q is 0 means it is a reset state. And for 1 0 we got Q is 1, Q bar is 0. From this I can call it as whenever we are giving 1 and 0 for to this SR latch, I am getting set state. Case 2 is set state, case 2 is in case 1 is reset state, case 3 is not used case. Whenever you are giving S is equal to 1, R is equal to 1, it is a not used case or indefinite state. Okay, these are all about SR latch. This is a very much important concept, because if you want to develop SR flip flop, RS flip flop, D flip flop, T flip flop, JK flip flop, master slave JK flip flop, all those concepts, the basic idea about the memory block and how to store the single bit number can be easily obtained from this SR latch. Okay, and this is the second SR latch, that is using NOR gates, using NAND gates. Using NOR gates are over now, just now. Using NAND gates. NAND gates are crossly coupled, and we are giving here S is first, R is next. In previously NOR SR latch, R is first, S is next. Based upon the design only, we are getting desirable operations and desirable storing the data in the form of single bit number. Okay, these are all about SR latch using NAND gate and NOR gate. Thank you for watching.